Hello, my name is Denis. I'm head of developer experience at ZetaChain, and in this workshop, we're going to be building a new Omnichain contract called Withdraw. It's going to be a tutorial on how to build Omnichain contracts and deploy them on ZetaChain. So let's go. So if you want to follow along, open ZetaChain documentation, go to the Withdraw tutorial, and the goal of this tutorial is really to understand how to call a ZetaChain contract from another chain, such as Goerli or Polygon. So what we're going to be building is a very simple contract that basically expects to be called, and when it's called, it sends the tokens transferred to it to a recipient address. So the way you're going to use this contract is you would do a token transfer to a specific address called TSS address. On each chain, this address is unique. So Polygon has one TSS address, BSC testnet has another TSS address. You would, as a user, you would send tokens to this address with value, and the value contains the contract on ZetaChain that will be called, and a message which contains recipient address to which the tokens will be sent. So this is just a quick demo on how to call Omnichain contracts from connected chains. So we're going to be using a template. If you go to github.com/ZetaChain, you will see a template. Make sure to use that, and let's get started. Let's remove tutorial, and let's git clone templates and put it in the withdraw directory. So this is a plain template for building Omnichain contracts with ZetaChain. It's already pre-configured. It has some tasks helpful for you to get started. So let's use that. So what we're going to do is we're going to create a new contract in the contracts directory. It's called withdraw. And this contract, well, first let's do some boilerplate. Solidity, we're going to use an older version for compatibility. And the contract is going to be called withdraw, and it's going to be a Z contract. So Z contract, if you go to documentation, you can go to concepts and read about what Z contract is. But basically, it's an interface that contains on cross-chain call. So this is the only thing you need to implement in your contract for it to become an Omnichain smart contract. So that's what we're going to do now. So we need to implement a function called on cross-chain call. So this function has three arguments. One is address, ERC20. Another one is UN265, 256 amount, and the last one is the message. So basically, all the chains connected to ZetaChain have native tokens, native gas tokens, and they're represented on ZetaChain as ZRC20. You can read more about ZRC20 in the docs, but it's basically an extension to your C20. It has additional functions and it emits additional events. So all the gas tokens on connected chains are represented on ZetaChain using ZRC20. Amount is the amount of tokens you are sending as a user to the TSS address, and the message contains the contract on ZetaChain that gets called, as well as additional data. In our case, that would be a recipient address. So what this function will do is it will basically do two things. It will get the recipient address from the message, and it will call another function called doWithdrawal that we'll implement next. So we're going to be using ABI decode to decode message, and we'll take an address from it, and we're going to store it in byte 32, and let's call it recipient. So that should pull out the recipient from the message, and now we're just going to call doWithdrawal and pass all the same arguments, except instead of message, we're going to call pass the recipient. Okay, so this function will be external because we want to make sure it can be called. Override. Okay, cool. So now what we are going to do is implement doWithdrawal. So function doWithdrawal. Call it doWithdrawal. We already know the arguments. We can just do that. And the function is going to be private instead of internal. Okay, this looks good to me. So what this function will do is it will use zrc20 withdraw gas fee to determine the gas fee of this operation. So we're going to use izrc20 and call withdraw gas fee. It's returning two values. One is address of the gas token, and the other one is the actual fee. So now we will do the we will approve the transaction and then withdraw. So izrc20 zrc then approve, passing the zrc20 token address, gas fee, and now we need to do the same but actually withdraw. So go back to documentation, you can see the arguments that withdraw accepts. One is the address of the recipient, and the other one is amount, but we need to account for the gas fee, so we're subtracting the gas fee, and we need to encode code packed recipient. Okay, so this looks good. One of the things we need to do, and this is only for the testnet, we need to update the gas fee multiplied by 2. This is something you would not need to do in the next testnet, but for now you have to use this workaround. Okay, now we need to all add the imports because we're using izrc20 and ZContract. So let's write the imports. So all the contracts or the protocol contracts are published on npm. So you can use ZEVM protocol contracts from the ZetaChain repo, contracts, interfaces, izrc20, and also ZContract. So if you go to npm, you will see this repo with the contracts. If you want to read the source code of the contracts, it's deployed It's published on GitHub in protocol contracts repo. So you can go here and inside the contracts directory, interfaces, you can find I0C20 and Z contract. It's the same as in the docs. Okay, cool. Now we need to add yarn add will install on all the dependencies. Okay, we're using a different version of Solidity than that comes by default with the hard hat template. So we're just going to update that in the config and run npx hard hat compile. Okay, it looks like we've got a little sign. Let's try again. Okay, this looks better. Okay, it has compiled the contract, which is nice. Now, what we're going to do is we're going to write a deploy script to deploy this contract. So let's implement this as a hard hat task called deploy TS. We can use the existing tasks to actually look up how it's implemented so you don't have to write everything from scratch. So it's going to be a task called deploy. Let's skip the description for now, and it's going to call the main function. So let's import task from hard hat config, and the main is going to be an asynchronous function that accepts 2 arguments. We can copy and paste them from here. It's basically an args arguments and the hard hat runtime environment, which we import from hard hat types. Okay, so what this function will do, what this task will do is it will basically use ethers to get contract factory by name, and the name is withdraw. Let's store this in a factory. Contract wait factory deploy. This is also requires a wait. And now we just await for the contract to be deployed. Let's also print out the transaction, the contract address. Contract address is going to be contract address. Cool. Okay, now we need an account. So we have a few tasks that will help you with account management and balances. So if you run npx hard hat, you will see the account tasks, balances tasks. So if you run hard hat account, it will just generate a new hard hat account. It will generate a new account. This is convenient if you need an address to send tokens to, for example, just a throwaway address. But you probably want to run it with save so that it saves the private key into .env file so that Hardhat can use it for deploying and transactions and everything else. So create a new address, and now you can run npx hardhat balances. So what balances does is it fetches the token balances from all the connected chains in ZetaChain. It's a new account, so it doesn't have any tokens yet, which is fine. That's why we're going to use faucet. So the faucet takes the private key from .env and requests tokens from ZetaChain faucet. It uses GitHub authentication to prevent spam. You can check that it's provided by ZetaChain. Give it a few seconds to actually process the request, and we can query for balances again. Okay, seems like we have 10 Zeta tokens, which is plenty enough for us to deploy a contract and interact with it. So now we created a deploy task, but we haven't imported it yet. So let's go to config and import the deploy task. And now if we run npx hardhat again, we should see the deploy here, and we can use it. Provide a network. So we're deploying this Omnichain contract to ZetaChain, and the current testnet is called Athens. So if you need to pass Athens to the network, and let's deploy. Okay, cool. So it deployed the contract to this address. Seems to be working fine. Let's query for balances and see that the balance should be updated now because we spent some tokens for the contract deployment. Okay, cool. What we're going to do next is we want to interact with our contract, right? So let's create a new task called withdraw. You can even copy and paste from deploy, rename deploy to withdraw, and we don't need this anymore. So what this task will do is it will send tokens from user's address to the TSS address. So signers will, we're going to be using send transaction. Send transaction accepts an object with 3 values, to value and data. So first we need to get the signers. We get them from, well, get signers function that will basically take the private key and generate an address, generate a wallet for us from the private key and the .env file. Get the signers wallet, and now we need to implement these 3 functions, 3 values, to value and data. So to will be the TSS address, and ZetaChain provides some handy functions. One of them is get address, which basically returns address of the, like if you need a TSS address, you can query for TSS address. It's coming from a package called ZetaChain addresses. So you can import that from get address from ZetaChain addresses. And ZetaChain accepts one argument, but it's an object, and one is address. And in this case, we need TSS. The other one is network name, which is the name of the connected network. And we're going to take it from hardhat environment. And the last one is Zeta network, which is the current testnet, which is Athens. Okay, that should be good. Let's fill out the value. So value, we're going to pass as an argument, so args value. But we need to parse it first. So we're going to use the parse ether function and let's import parse ether from ether's project units. So the last thing we need to do is implement the data, well, get the value for the data, and the data in this context will contain an address of the Omnichain contract on ZetaChain plus the recipient address. So we need to concatenate them together. And we're going to use a helper function for this, prepare data. I'm going to pass contract address and recipient. Now what we need to do is implement prepare data. So prepare data will just return two values concatenated. One is the contract and the other one is recipient. But we can't pass recipient directly. We need to process it first. So let's process it and call recipient bytes, and we'll use Ether's utils hexify function to convert the value to hex, and we need to pad the value using 0pad recipient. And let's make sure to use recipient bytes here. We need to slice it to remove the first two characters so it doesn't contain 0x. Now it should be ready. Okay, cool. So the only thing that's left is we probably want to keep this inside a tx constant and console log tx, just so we can find this value later on. Okay, this looks good. Let's add withdraw function into hard-hat config. We're going to be sending tokens from a connected chain, so we need to acquire these tokens first. We have Zeta tokens, but we're going to be using Polygon in this example. We don't have Polygon tokens yet. So what you can do is you can do a web search for a Polygon faucet and use this one, for example, provided by Polygon, or you can use the one provided by Alchemy. I'm just going to send tokens to our address from my own address. I already have Matic tokens. Let's send 10 tokens, should be enough. Confirm. Let's wait a bit for the transaction to process. While we're waiting, we forgot to implement arguments. So we're using args value, contract, and recipient, and we need to add them here as params. So add param contract address on ZetaChain. Add param recipient. And the last one is value, amount of tokens to withdraw. So that should be enough. Let's try querying for balances again to see if we got the tokens. Okay, cool. Let's compile the contract again and deploy it just to make sure that we're using the latest version. Okay, and now we can use the hard hat withdraw function that we just the withdraw task that we just created. I'm going to pass the contract address, the one that we just deployed, recipient. For this recipient, let's actually create a new account. It's going to be a one-off account just so that we can have an address. So again, hard hat withdraw, contract, this one, recipient, this address. So the value will be 5 thematic tokens. Network is Polygon testnet. Okay, that looks good. Let's try executing this command. Okay, we got a hash of a transaction. Let's go to Polygon Explorer and check if this transaction succeeded. Did. Now we can go to ZetaChain Explorer and check the same transaction on ZetaChain. It takes a while for it to get indexed. Okay, let's give it a second. In the meantime, we can actually check for balances again, just to see that our tokens were sent from our account. Okay, now we used to have 10 tokens, now we have 5 tokens, which is good. Try again. Okay, in the meantime, we can check the balances of the recipient. I don't think it's processed yet, but it never hurts to try. We're now checking the balance of the recipient. Hasn't processed it yet. So let's wait for ZetaChain to pick up this transaction and actually do the cross-chain token transfer. Cool, it looks like it has succeeded. So you can see it sent from Polygon to ZetaChain. Now let's query the balance again. It may take some time to process this. Awesome. It took some time, but we can now see that the balance of the recipient has been updated. So we sent 5 thematic to the recipient. Some tokens were used for gas fees, but the recipient received tokens. So congrats, you built your first Omnichain smart contract using ZetaChain. And just to recap, what you did is you wrote a contract that sends tokens from one address. So the contract actually got called from a Polygon blockchain. So you deployed a contract to ZetaChain, and then you send, as a user of Polygon, you send tokens with a message to a TSS address. ZetaChain picked up this transaction, passed the tokens, called the on cross-chain call of your contract, executed the logic, and the logic was just to withdraw the tokens to recipient address. And we can see that the recipient address has been updated. Congratulations. See you in the next workshop.